Yeah, hi. I'm Lena. I'm her wife, or his wife. It's my husband. Okay, so I I work for Canonical on Ubuntu and Debian. I do a lot of open source packaging, this, that, and the other. And Lua is something that I use relatively often, not entirely, but it is its own package in Ubuntu or whatever, Lua 5.4, and that was a package that I added to the main repository of Ubuntu, so we do security development and stuff on it. And I've been working with Love probably for like the last 10 years, but very on again, off again, in that I started on in like high school and stuff, and then have not used it for a long while. So seeing some of the new features has been really cool. So this is learning to love game development, designing games with Lua. So how many of you have heard of Lua? Yeah, just in general. Nice, okay. And then how many of you have heard of the Love game engine? Nice. Okay. So yeah, just like, 50-50 there, which is perfect. This will pretty much go over all the basics and stuff. So Lua, as a concept, it's a programming language. According to the lua.org website, it's a powerful, efficient, lightweight, embeddable scripting language. You can read the rest if you want. But basically what it's used for is many different purposes. One is to embed within other software, so you'll see it a lot in gaming mods and stuff, such as Minecraft. If you do a mod for Minecraft, you can add Lua to it, stuff like that. It's been used to create full games, stuff like Angry Birds was created in Lua, so stuff like that. And of course, Balatro, which I'll get into later. So some of the history of Lua as a concept: it was first designed in 1993 at PUC Rio. It's the Catholic University in Rio de Janeiro. And it was just created for like local projects and such. And they were really only maintaining 2 projects in Lua up until its first public release, 4.0, in November of 2000. And yeah, it's been a lot slower in development since then. We're only up to 5.4 now, and that was released in 2020. 5.5, who knows when it'll come out? Eventually, probably, but usually it's like several year wait times per point release. But right now we're on like 5.4 point something, so they do a third point for each security update for a version. So developing with Lua in general, I'm just going to go over the general syntax of using Lua and some of the control structures, that sort of thing. So here are the reserved tokens for Lua. So these are all things that Lua will see when you run the program, and it'll be like, okay, this is an if statement, okay, this is an else statement. So you can't declare a variable as any of these, and these are all the tokens that you'll see for comparisons and creation of objects, that sort of thing. And I'll get into where these are actually used. So for Lua syntax, in terms of types, you have some of the more simple types, such as the nil type. So in Lua, there's 8 different types, and they decide basically types are decided by the value. And so nil is your classic null. Basically, it's a 0 value, but not 0, so it's an undefined value. And then you have your number value, which can be either a float or an integer. And it decides whether or not it's a float or an integer based on what it's described as. So with the IEEE format for a float versus an integer, it can determine that on the fly. And it'll automatically switch back and forth depending on what you're using. And then a string, it's just a set of bytes, essentially. It's just immutable bytes. So it can be any like 8-bit anything. But if you send it out in just characters on there, it'll determine the ASCII value or Unicode value or whatever, and then maintain that in there. And then there's Boolean. It can be true, it can be false, it cannot be nil, it's just true or false. And going over these types, so yeah, there's no explicit type declaration. As you saw, you don't say int blank equals this. The values are what determines the type. So if you have a string, it's a string. And nil is a falsy value, so if you say something is not this and it's a nil value, then that'll result in true, stuff like that. And then numbers are by default internally represented as 64-bit. So it's a 64-bit float or a double in C, or a 64-bit int, which gives you a wide range of values by default. If you're looking to write Lua for like an embedded device or something, you can always use the Lua 32-bits macro in the definition when you compile your program. By default, Lua is an interpreted language, so it runs at live, just-in-time interpolation. But you can still compile it basically into a C library, essentially. And yeah, strings are arbitrary immutable byte sequences, so they can have anything within them. Yeah. So, okay, there's also a few more advanced types. There's the table, which is basically a JSON object in general, and it can contain a set of whatever types, and they're enummed out. So you can have a variable within the variable, essentially. And you can define it with the variable name, just equals, so you're just setting equal a variable, and then outside you have your object, and that contains all of it, and that's your table. Arrays are also just tables. So they're tables with indices that are just integers. Oh yeah, so yeah, here's that. And then here's printing an object from the object. So now you have functions, which is a type in Lua. So you can, set a variable equal to a function or move functions around and stuff. Classic. So yeah, with a function, you declare it like this. In Lua, spacing is arbitrary, so it doesn't care how many spaces are between any tokens or whatever, unless it's 0 spaces, in which case it's 1 token. So you could have like function and then enter and then and, or function space, and, or whatever. It just determines what's in between the spaces. And so you have function, that's your keyword to describe a function, and then your function name, your arguments. You don't have a return variable. That's just determined when you return. And then to call a function, it's pretty straightforward. It's like any other language. You set whatever your result equal to, add. And you can also have multiple outputs. So you can say like the sum1 and sum2 with a comma to create that. So yeah, here's an example of using a function within a function. So you can return a function from a function if you want. And then that's essentially like using lambda functions or whatever if you're doing JavaScript. So yeah, here's a general function, and then here's a function that returns that function. And here's this setting this variable equal to the function and grabbing it. And here's printing the function call. So for Lua syntax and advanced types, there is also the coroutine and thread. This is a really important part of Lua in case you want to do multi-threaded programming. So yeah, it's both considered to be a coroutine or a thread. They're interchangeable names. But to declare a coroutine, you just say coroutine.create, and then within it, a function value. And then that function will run through whatever coroutine thread you run. And you have your yield value here, and that basically just stops the function until you do a resume call. And so then down here, you can say coroutine.resume, and resume can start the coroutine initially. So this will start and print out 1, and then, yeah, you can continue on from there up until the coroutine ends.
I know you haven't gotten to Love yet, but generally game engines operate with an event loop.
Yes.
And does Love play nicely with coroutines? Because it's cooperative threading, right? So I'm interested in like, how does the event loop handle coroutines, or you just not even bother with that?
Yeah, it does play nice. I mean, because Love's coroutines are also just coroutines. So it'll basically run the coroutine that you create within a coroutine as another coroutine. So it's technically a child coroutine, but it can run at any point. So they work fine together. And I mean, if you have the pointer to the coroutine or the variable connected to it, then you can call it from wherever and be like, hello coroutine. Yes.
Is there a way to do something when the thread like ends, when your action's complete?
There's, I think, a coroutine method that allows you to detect when a coroutine ends or whatever. But when it ends, it just kills the thread essentially. So yeah. And then one more advanced type is user data. I didn't do a full example of this because it's a bit more complicated, but basically if you want to interact with the memory of a C program on the C stack or interact with Lua on the Lua stack within C, then you can use user data, because user data essentially contains C memory. And it allows you to call a C function, or it allows a C function to call a Lua function interchangeably. And this is one of the most often used things in embedded Lua. So when you embed your Lua in a different program or whatever. So moving on to various syntax and statements and such, here's an if statement. So with the if statement, you have if and then any number of spaces and then your determination. In this case, x is greater than 10. So it's similar to both C and Python in this case. So you're greater than, less than, equal to. Yeah, it's more so Python-y. Because you have your and spelled out, your or spelled out, your not spelled out. So it's not an exclamation point or any of that. So yeah, here's the if, and you have to have a then after, because that's how Lua determines, oh, this if statement has started, everything past that then is within the if statement block. And then instead of elif, like you would see in Python, it's else if. It's just different naming. And yeah, you still have then with the else if, and then it knows it's in an else if block. And then else is just else, just like Python. And then you always have to end with an end. Otherwise, it doesn't know that it's exited the block. And then here's loops, very similar, except now instead of then, you have do, and end is still the same. It's just an end statement. And for for loops, you have inherent iterators in here, similar to Python again, where you have your initial value and then your final value, and I think you can add a step value if you want. And then for indexing, so here's an example of using a table as an array. So basically you just create a new array and then you set values to integer values, or to integer indices. And that's all it is. It's just a table like that. So that makes the array dynamic. It can be any size, and your indices don't have to be consecutive. So you can do indice -1, indice 5, or whatever, and it's still considered an array. But if you want to use a Lua library at all, the general convention is that the index 0 starts at 1. So
The right way.
the controversial way, I guess, the MATLAB way. So yeah, if you find yourself calling to a library and it's breaking for some reason, but it's still running, it could be that. It could be that you're just indexing wrong. So always start with 1 whenever calling a library, or just as best practice, use 1 as your first index in Lua. It'll just help you out in the future, even if it'll mess you up with other languages. So for environments, you have your local environment and your global environment. So a global variable is global. It can be accessed anywhere in the Lua stack. So if it's in another file or whatever, it can still be accessed. If it's in a different function. If you declare the variable within a function, such as the b = 10 right there, that can be detected anywhere else. So that also works with coroutines and stuff. If you have a different coroutine and you call that global variable, it'll be that value, but then you have your race condition or whatever. For local variables, it's local to whatever control block you're in, and it'll only stay that way. So local high over here is accessible from anywhere in function tests below the call. And then local y = 2 is only accessible within the if statement. And you have local variable shadowing, so the furthest down, basically, the furthest down control block, that is the overshadowed value. So when local x = 5 down here, that means the x = 10 is overridden for within this function. Not outside, of course, because it's a local variable. but within and everything below, it'll consider x to be 5. And then garbage collection, it's important to know that Lua collects its own garbage, so you don't have to free any pointers or anything. It's completely automatic, and it's based on variable scope. So if you have a local variable and then you exit whatever control block that's in, eventually it'll just get deleted because now it's a weak reference. And for the options for garbage collection, there's incremental and generational. So incremental is where it does a tag of each of the variables as they leave, and then it sweeps them out eventually. So there just takes some time at some point when things are kind of like not too expensive, and then it just clears out all your old variables. Generational does just kind of consistent clear out of your values. And you can decide which one you want. By default, it's usually fine. It depends on the Lua interpreter which ones it uses, but usually I've seen incremental with the official one. And it doesn't matter too much unless you're in a real performance-intensive situation, in which case you may or may not want to use Lua. It is a very efficient language, though. And yeah, if you want to learn more about garbage collection, there'll be a link, and I'll have a link to the slides at the end. And yeah, here's additional info for your reading. So now we're getting into Löve, the actual game engine. What is Löve? Baby, don't hurt me. It is an open source library for 2D game development. Basically, it contains a bunch of library functions for graphics, physics, I/O, networking, event handling, this, that, and the other. So you can play sounds, you can interact with keyboards, display images, all sorts of things. And it's done entirely with code. So what isn't Löve? It's not a full game development application. It's not like Unity or Unreal Engine or Godot or any of those, which have their full graphical user interface with all their like subcomponents and object interaction and stuff. It is pure code. And so how you develop in Löve is you write pure Lua code. Some history of Löve. Its initial release, 0.1.1, it was called Santa Power. It was made in 2008. I think I started using Löve around version 2-ish, somewhere around 2010, 2012. And then the current release is called Mysterious Mysteries. We're currently on 11.5, and that was released in December 2023. So the release schedule is a bit slow, but that's fine. Bestest Friend is coming out eventually, but there's no specific news on that. And so here's some games made with Löve. Balatro, you've probably heard of it. It was up there with the games of the year last year. And it was made entirely with Löve. And that's really cool to see, like a huge major game release coming out there. There's a lot of other things that have come out in the past, less famous, I guess, like Move or Die and Mario Zero, or Mario, the Portal Mario sort of mini game. That was really fun. And the platforms you can distribute Löve on: Windows, Mac, Linux, Android, and iOS too. With iOS, you need a Mac with Xcode to develop for that, as you do generally for iOS. And for Android, you can use Android Studio, APKs, that sort of thing. And Windows, Mac, and Linux, it's basically just the pure Lua, and you just use the installer, run it, and you can zip it up and distribute it.
Are you able to comment on, so Balatro
Yeah.
was on Switch and PS5, I assume it was on all the big ones. That's an assumption on my part, but clearly it's possible to get a Lua game there. Do you have any idea how that works, mechanisms to actually like publish?
Yeah, I mean, I can imagine a way that they did it. I'm not sure how specifically Balatro did it. I mean, for releasing on desktop or whatever, they went with more or less the standard route. And with Löve, it's actually fully open source. Like, the code that you write is fully open source because of how you package Löve, because it's just packed Lua files. But on the PS5 or Switch or whatever, I'd imagine they used basically a base layer, some sort of application interpreter, like the general Nintendo Switch application or whatever, and then on top of that they embed a Lua runtime, and then on top of that they embed Löve. Because you can embed the Lua runtime into just about anything, because it's basically it can grab onto like C memory and C libraries or whatever and just run on top of it. So yeah, installing and running Love. So if you want to install it, it's really simple and there's not a lot to it. Like you can download it within a few seconds on a small connection. So for Windows, if you go to love2d.org, for any of these, if you go to love2d.org, you can grab the installer. For Windows, you grab the installer, you install the installer, and then when you want to run your game, you just drag the game folder with the main.lua on to the application, and then it just runs it. Otherwise, you can open up your command line and just run love and the name of the folder for your project. For macOS, it's a very similar story. They just have a zipped macOS application at the same place, and you also just drag the folder onto that application. Or you can run with a more specific command, which you're just opening the Love application and then running the folder. And then for Ubuntu, my favorite, I work on this operating system. It's already in Ubuntu. Sudo apt install love, that's it. Granted, that's for the latest release. If you want to keep up to date with Love, they have an active PPA, which is a personal package archive, and their official one is just Bart Bay's Love stable. And that's just one of the developers who just consistently releases newer versions on older versions of Ubuntu. And this person's been releasing it on like really old versions of Ubuntu. So if you want to install it on like 14.04 trusty tar, there's a version of 11.5 ready for that. And then easy to run Love on Ubuntu, you just run love folder name. For other Linux, I'd build from source, sorry. And then yeah, there's getting started in case you want to look at it later. So using Love's libraries, here's where we get into the real meat and potatoes of the actual game engine. So here's your Hello World program. You basically just print text, Hello World. And now I can actually show examples. So I've created a makefile in this presentation to just run them straight up. So that's why I can just do make p1 for this. And I'll have a link to the GitHub. It'll have the presentation and all these examples at the end. There it is. Not very impressive. It just says Hello World in the default font, super small, but that's intentional. This is the default Hello World that they give you, not much of anything. But that's just where you start. So yeah, in Love, your main function of sorts is love.draw, and that's what draws to the screen every frame. It's just a frame-by-frame function. So the game engine itself just calls that function repeatedly every single frame. And love.graphics.print, that's just one of the library functions for printing Hello World to the screen at 400x and 300y. Now note that 400 is x from the left to the right, so 0, 0 is actually at the top left of the screen, and 300 will be 300 down. So if you are used to a regular Cartesian coordinate system, which is like fair enough, you'll be maybe a bit surprised. But if you're used to, CSS and HTML, this is the same sort of thing. Yeah.
Does it start from 0 or does it start from 1 like Lua?
It starts from 0, 0. So, yeah, I mean, if you're indexing the screen, I guess they already broke it. But yeah, here's, yeah.
So this, you said this gets drawn every frame. If you have something intensive, I would imagine you could miss frames, right?
Mm-hmm.
So is there a way to get like the time delta? So if it misses 5 frames, I don't know, and you need to interpolate over the 2 different draws of what you're going to draw, and you've missed frames, like how do you deal with that with your drawing logic? Is there a way to access the time delta of what's happening?
Yep, there's actually an exact way to do that. So love.draw, that's more for graphics, so it's what you want to call every frame. And if there's drop frames, that's fine because it's your graphics. You want the frames. So love.update, which I'll show in a bit, is actually how you update with a time delta known to your function. So here's just a basic example on images and windows, handling them. Yeah, I know it goes off screen, but I can scroll, don't worry. So initially you have love.load. So this is your initial function. It runs on startup after everything's booted up in the Love library. It calls this function, and you can initialize anything here. So if you want any initial values, global variables, you can also declare global variables outside of this, but as you can see, I've declared the variable whale here, and it can be accessed anywhere because it's a global variable. So window.setMode allows you to set the size of the window. Yeah, here we go. Okay, so yeah, window.setMode allows you to size the window 800 by 600 in this case. I'm allowing it to be resized, and the minimum width and the minimum height are also things you can add to like the additional object for information about the window. And then you can set the title of the image, or title of the window to scale image. And then you have like a whale.png. And then draw will allow you to draw that whale. So in this case, I can show you that example. So here's a whale, and it scales as you stretch and compress the screen. Now this is not necessarily how I'd recommend you do it, because there's the ability to do background images and such, but this just shows that you can scale an image to the window size. And yeah, here's how you do that. So you can get the width and height of your entire window, and that's with love.graphics.getDimensions. And then you can scale the size of your picture, of the width of the picture divided by the width of the whale image itself. And then you can draw an image with love.graphics.draw. You draw the whale image, and I draw it at the location 0, 0 because I'm drawing it in the top right, and then with a rotation of 0. So you can rotate in radians your image. And then here's me scaling the image to the size of the screen. And yeah, I guess I do have highlighting, so I know how to use that. So for system information, you can also get that too in Love 2D. So yeah, here's me just setting the window and title and such. And then I can also include a font. So in this case, I'm including the Ubuntu font, and I'm making it size 80. And then you can set the font with love.graphics.setFont. And then you can draw whatever text you want with print, and it'll print in the new font. And then here's some of the things I can get. So I can get the operating system type, and I can get like info about what power you want. Is your device currently charging, or do you have a battery, that sort of thing. And I can also get the number of processors, which is really useful for getting a vibe check of how good the system is going to be when running whatever you're doing. And then I can also get the current frames per second. So yeah, if you have drop frames, Love notices that, but it doesn't show the frames. And then of course you have love.timer.getTime. So that's the amount of time since startup of the program. So if I run that, here it is. OS Linux, that's as much as it can determine. If it really wanted to, I'm sure it could determine more, but the library just says Linux. And it says my device is currently charging. It's at 99%, not quite there. 8 threads on the system. It's a bit of an old guy. And an FPS of 60, so it's running it just fine. But you can see it drops a few times here and there. And 60 is the default FPS of a Love program. And it may go lower, it may go a little bit higher just due to how it calculates things. And then, yeah, it's been 34 seconds since I started talking about this.
Is the font global? Like, or different question. How would I render 2 fonts of different sizes, or different fonts on one draw?
Yeah, so all you have to do is love.graphics.setFont in between your prints or whatever. So it's just setting the font for what's going to happen in the future up until it's set to a different font. And it'll maintain whatever was already printed on the screen with that font.
Okay.
Up until next time. And yeah, so if I just change the font a few times here, I can do that. But yeah, if you have a TTF font file, you can just include it in your project, and it'll determine from that. Yeah.
Can you scale? I don't know if you know. Sorry. Can you scale the size of the font based off of the? Is there a nice way, I guess, rather, to scale the size of the font based off of the window size? Obviously, you could like calculate it out, but
Well, I mean, you can, I guess, scale the size of the text based on it,
Yeah.
because there's additional parameters. So right now, the only parameters I've used are the X and Y location. But I believe you can, I don't think you can scale a print actually, but if you were to, I guess, increase the font size, so, but I think you can modify your, so if I went Ubuntu font dot size or whatever, I can modify it there. And then you would just have to determine the point size versus the size of the screen. And then, yeah, here's a situation where I'm printing time-elapsed here. Okay, so now for physics, one of the more fun parts. So when using the physics engine in Love, there are a lot of external engines that you can like include in your project that have more advanced physics situations, but the default one is pretty good for getting gravity, velocity, bounce, that sort of thing. So in this case, for physics, I am initializing a few variables. I'm initializing my gravity at 9.81, and I'm initializing the size of a meter as 64 pixels. And the whale is coming back, spoilers, it's going to be 50 pixels in radius. So to set the size of a meter, you do love.physics.setMeter, and then it determines how much a meter is in terms of pixel size, or number of pixels. And then you can create a world. And in Love, it has the concept of a physical world. And within this world, you decide whatever physics happens. So you can have multiple worlds going on in a Love 2D game on top of each other if you want. It's just whatever bodies are associated with that world will follow the physics of that world. So in this case, I have my new world here, and gravity times meter size is how fast you accelerate, essentially. The true here is allowing you to freeze objects. So if you want to freeze an object outside of physics or whatever, you can set that to true, and then you can freeze a body.
Does that mean just like take it out of physics calculation for a time? Or?
Exactly, yeah.
Okay.
And if you set it to false, everything will maintain physics from then on. Okay, so here's my declaration of a whale. So as you can see, here's me using a table. It just makes it a bit easier because there's a lot of variables associated with this physical body, I guess. So you have your image portion of the body, and this table can be whatever you want. But here I'm including the graphics portion, which I'm including the whale again. And then I'm setting the scale of the whale. And then whale.body is the important part. That's where you create a new body within the world that you want to use. And I'm setting its initial location of 500x, 400y, and it's a dynamic physical object. So there's a few options for types of bodies. There's rigid bodies and dynamic bodies. And you can just go into the Love wiki to get more info on each of the body types. And then whale.fixture, so you need a fixture for your body in the world. This is why you want a table for everything. And a fixture essentially determines the shape of your body within the physical world. So when it's hitting and colliding with other things, it knows how the shape works. So in this case, the best shape for it is a circle, which is the whale shape right up here.
Have you worked with Godot?
Yes.
So is this comparable to like a collision 2D?
Yeah, it's
Okay.
it's very similar to that, just written in Lua, I guess.
Got it.
And then restitution here. So here's actually a way you can call a subfunction of a object. So variables can have like functions within them or whatever. So you use the colon to call that function. And so restitution allows it to bounce off of another body. And then, yeah, so for this physics initialization, I've also initialized a dragging and a whale mouse joint value. And for this example, I'm going to be able to use a mouse to drag around the physical body. And so I need to know if I'm actually dragging the mouse at any given time and if there's an active joint attached to the mouse cursor. And so, yeah, here's using the mouse with joints. So love.mousePressed is essentially an event function. So this is called on the event that your mouse is clicked. Any of the buttons on your mouse, it doesn't matter which one, it'll give you the button. And so for this, I'm looking to see if button equal 1, that means is the button a left click? And if so, I'm going to determine if the distance of that click, or where your cursor is within the distance of the size of the whale. So that means, did you click on the whale? And if so, then we are now dragging the whale, and I've created a physics joint between the cursor and the whale itself, or really the point in which the cursor currently is and the whale. So that way, whenever the whale is floating in free space or whatever, and it clicks with a joint there, then it'll be attached to that joint at that location on the object, which means it can do its standard rotation and stuff as if you've nailed it to a wall. And then whenever I move the mouse and I am currently dragging the whale, I update the mouse joint location to match wherever the cursor currently is, so that way I can move it around. And as you can see, you have a X and a Y location for the cursor, so where has it moved to, but you also have a delta for where it's moved from. So you can also get like the velocity of your mouse if that's useful to you. And yeah, so I'm setting the target of the mouse joint to whatever the location is. And then whenever I release the mouse, I basically fling the whale off into space because I've released the joint, and now wherever it's physically moving, it's going. And okay, so now here's love.update. So this is what you want to use when you're using physics or determining any variation in time between calls. And you have your DT. So your delta time is the time in milliseconds since the last time this update was called, essentially. And so I can tell the world to update with the delta time of the delta time from the last update. So it'll just update the world that amount. And this is one of the most standard like love.update functions you'll see in any love project. And then drawing it, basically I am drawing a ground rectangle on the ground, and it just is some green grass essentially. But I have the points of the rectangle that I'm drawing, and it gets the points of the world and fills a rectangle. And then here we have me setting the color to 111. So that means I'm setting the color to white because you can actually change the color of an image by scaling it out based on the current color. So if I were to leave the color at 0.1, 0.7, 0.1, then I would have a green whale. And then I draw the whale as is usual. Draw it in its current location with the current radius. It's a very long line of code, but it's just drawing it.
I think I missed the ground.body.
Yeah.
Where did that come from? I apologize.
Oh yeah. I actually created. Oh, so some of the code from this is missing. I deleted some of it, and I must have gotten rid of it. But I created a ground object too, and the ground contained a rectangular body.
Okay.
Yeah. So if you want to look into the full code base later, it'll be included in the GitHub.
Cool.
But yeah, here's running the physics. So I also added another rectangle object of the logo on my website just to show like a rectangle moving around in space too. And here's what it looks like. So as you can see, the whale bounces a bit because it has the restitution value, and it can collide with other objects. So I can send that off, and then I can fling this out into space.
You monster.
Yeah, so there's that. So shaders, this is one of the big things in Love 2D. And this is really what made Bellatra what it is its shaders. Because it does a lot of crazy things with all of its cards and the movement of things. And it's all done with shaders, which is a really powerful tool. And essentially what shaders are in Lua and Löve, Löve uses GLSL shaders, which is a shader language, which allows you to mess with vertices, mess with colors, and that sort of thing on top of objects, and you can define it through that language. So in this case, I'm creating a rainbow shader that also like has a ripple effect on the whale. And to do that, I'm essentially just doing love.graphics.new shader and rainbowripple.glsl, which is a file I've included right next to the main.lua file. And for love.update, you can see I will send a variable to that shader, and it'll keep that variable in mind and determine what to do with that variable based on its definition. And then with love.draw, I basically set a shader, and I set it to the rainbow shader, and then I draw whatever I want to draw, and then I unset the shader so that nothing else gets drawn with that shader. And here's an example shader. So when using Love2D, you tend to do the Pragma language GLSL3. That way you use GLSL3 interpretation. Otherwise, I think it'll use GLSL2, which there's just slight variation in the syntax. But just going over basic shaders, this isn't really a full shader deep dive because that's years of work essentially. But here's a few functions that allow me to do things with shaders. So effect is the variable that actually goes into effect on a Love2D project. And in this case, it's returning a 4-part vector, so an XYZW vector. And with that, here's the final result. I basically mixed two things. So starting off, I use my ripple effect that I've created right here, which essentially has, it just creates a sine wave and a tangent wave, so that way it like ripples out from an image. It'll make more sense when you see it. And then I manipulate all of the vertices on that object to match that sort of ripple effect. And then I also want to change the color, because why not? So I want to use a hue value based on the time and just change that hue value over time so you get kind of a rainbow effect. So with that, I want to do the HSV to RGB. So I want to just use hue to change the full rainbow of colors. And basically this function, it's the standard algorithm for changing an HSV value into an RGB value. So that way I get the RGB components to add to the effect. And here's my color for that. So the texture color of it, because it does technically change the colors of everything. So it's a essentially RGB vector, is I create a texture 2D from the texture of that UV change. So, and then on the rainbow color or whatever, that's just the rainbow color, but I've made it at a 0.5 opacity, so that way you don't lose the image completely to the rainbow. And then I just mix those two things together, and here's what I get. Rainbow.
So my brain kind of wants to explode looking at that
Exactly.
shader code. Is there a library of like well-known shader algorithms and techniques that can be leveraged so I don't have to write my own shaders?
Indeed there is. So for more resources on shaders, Moonshine is actually really useful. So it actually provides you Lua-based shaders. So you essentially just import a Lua file and then include that inside your project, and then you can use that shader as if it were like a Lua thing. And I've actually gone ahead and done that on this example. So if I press space on here, here was a fog shader before I scaled it. There we go. And it just has a rolling fog over the image. And this is just included with Moonshine. And so if you want to learn how to do that, you can just use that example project to see that. And that's it. That's all I have. Here's the link to the GitHub if you want it. And it'll provide you everything you need. Yeah, any questions?
Yeah, can you comment on like shader performance? Is that like is Lua gonna quickly like run into trouble if you have a bunch of these shaders? Or like limits or?
Yeah, shaders are actually like extremely performant because it's hardware accelerated. So if you have like a proper graphics card, it knows how to understand GLSL3, and it'll manipulate your vectors in a parallel way. So it will not destroy your CPU or anything. I mean, depending on what device you're running it on. If you're running it on a heavily CPU-bound system that's like emulating graphics, then yeah, it's gonna slow things down. But that's really the magic of shaders, is that it is hardware accelerated and it handles things in parallel because it's all just manipulation of vectors.
Okay.
Yeah.
So Lua is like an embeddable language, right? And that means it's often used for mods and stuff. Does that mean that you can use Love for everything you use Lua, or is it kind of a separate thing?
I mean, technically, because Love is written in Lua, so you could embed it in something. You could use a lot of the functions. A lot of Love itself kind of works with like syscalls for a specific system or whatever, and so there's like ways that it exports out to Android, iOS, etc. But past that, you can probably just dump it on top of any really C application with a graphics system inside it and mess with it either way.
Have you looked through the Elatro source code yet?
I've been meaning to, because it's open source technically.
Yeah, well, I mean, I guess technically you have to purchase it.
Yeah.
Yeah.
I've got it on Steam, so
Yeah.
unfortunately this is my secondary laptop because the screen on this one broke, but I have Elatro installed there, and basically if you go into the Steam apps and the files itself, then you can just actually find the .love and within it all of the Lua files. So if you want inspiration, buy Elatro and dig into it a bit.
Do you have any opinions on like how best to change scenes, like from a main menu to like an actual game level, etc.?
My personal ideal is to just have scenes in different files or whatever, and kind of define whatever objects are in that scene within that file and define your physical world there. That's like the way I found to best syntactically split it up, and then determine like which scene to go to in some main scene transition function. But that's for larger games. Otherwise, yeah, just having it in separate files or separate functions is good enough for me.
Is there stuff in there for menus and that sort of thing? Like, every game has some sort of way, like it's started to get in there. Well, not every game, but most games have ways to interface via menus, pause, go to different levels, whatever. Are there tools for that?
There's definitely tools for that. By default, Love as an engine doesn't come with like a menu tool or whatever, but more than enough people have written like a drop-in menu tool essentially. But all of the like base level resources are there for you to create a menu, because you can freeze your physics, you can do this, that, and the other, you can include images, but by default there's no like love.menu. Yeah.
I've got more questions because I'm curious, a curious person. Particles are fun. Does Love have particle libraries, or have people written them, or is it built in?
Yeah, people have written a lot of external particle libraries and stuff. If you want to create particles on your own, I'd use a shader for it.
Okay.
And that's the most performant way to create particles, rather than creating a bunch of little objects. You can create one shader and it will just do vector math on it, and it won't be too intensive.
And then from a limitations perspective, Love is clear. I think it's got 2D in the domain name, so it's clearly intended for 2D stuff. So setting aside that you wouldn't really use this to write 3D games, have you seen other like limitations that people should be aware of about Love that kind of can put a constraint on creativity, I guess, put it that way?
Yeah, I mean, since it is, Turing complete, you can do basically whatever you want on there, but it doesn't have a lot of those internal optimizations that you see with like a full maybe Unreal Engine or whatever. They have a lot going on in there to determine things automatically. With Love 2D, you have to do just about everything manually. You have to make sure to set up your events and have them get called and such, and you have to include all your graphics and all of this, because you're essentially just writing a program. And really that's the biggest limitation, is you have to code. You don't get to drag and drop, which has its own benefits too, because then you're messing with it kind of more directly.
Does Love support any sort of signaling system like you're planning to do?
Yeah, so it has the concept of events. So yeah, you can, I mean, it's similar to, let's see, it's similar to like when you're calling for mouse events or whatever, like mouse moved. That's just a default event. It can also be whatever you want. So you can create your own event function, and that can be called and signaled to from a different event or whatever. Yeah.
Is the dot just a valid like character for function names?
Yes. Yeah, because it's not a reserved character, I guess. So yeah, you can call it love.mousemoves. That just is all in all its own function. That's just a way that they show that this is a love subfunction. So it's just their sort of syntax, but you can call your function whatever you want to call it, as long as the full token is not something that's reserved. And also, like, some of the symbols you can't do that with, like the greater than symbol or the less than symbol, but with the dot, yeah, you can.
Do you have to do a require on love, or is it just kind of like it just magically figures out that? Because that, to me, that looks like a table syntax where love is the table, and there's a function attached to the table, which is, you know, just a hook basically into that. But do you have to at the top say require love, or is it just kind of figure it all out?
Love will figure it all out, at least in the main.lua. So how it figures out that it's using love is that your main file is main.lua, and then you include your other files from there. But you don't have to include love as a concept, because love is running the main.lua file.
Okay.
Yeah.
In your shaders, I think you included time though, right? And it had some weird like extrand or something for the word.
Oh yeah. That's because it's GLSL and not Lua itself. So I guess shaders are kind of like the exception to the Lua rule of including in code, just because this is the GLSL3 language. So extern float time, that's the float you can actually call to from here. So this is me sending that time value to the GLSL language.
Oh, okay.
Yeah.
I see.
And that way it can use this time value, whatever it may be, for the whole file, and include it in whatever function you're running.
Will it fail in diagnosable ways if you forget to include, like if you try and reference something, or like how's the error messaging and all that sort of stuff in working with love?
It's pretty good. It'll tell you what line number something crashed on. Basically, you'll get a blue screen of death, like a literal blue screen, and it'll give you a Lua runtime error, because since it's not pre-compiled, it'll give you a runtime error, which is generally more of a pain in the ass than a compile time error. That's why Rust exists. But it's still relatively diagnosable. You'll know what line things crashed on, and it'll give you the whole fail stack. I don't know if I could quickly show that, but I guess I could. Oh my goodness. Ignore the
Beeping.
yeah. So if I just delete a character here, so it's not a valid function or whatever, and then make p2, this is the sort of thing you get. So it realizes, okay, at the second line, what is settled? It's not a function. and then it gives you the control stack. So
That's good.
also, if you have a game in production, you might end up with this.
I mean, it's better that it fails fast for you
Hmm.
than silently carries on.
Yeah. And as you can see, I can't like select the text, but it does say press Control C. So if I press Control C, I can grab the whole stack and basically, yeah, print it out.
Cool.
Yeah.
Are there, so Lua can work with C,
Mhm.
being a program itself written in C. Foreign function interfaces, are there like C libraries that you can use with Lua, or they tend to be packaged up as
Mhm.
other Lua packages? You can comment on like other things that are out there that might. I'm trying to think of like, we want games to be performant, and some of these things probably
Yeah.
have to be written in C to be performant enough. Is that a common thing to use? Is like C-based packages to support these things?
Yeah, you could definitely do like a hybrid sort of thing where you have some Lua written here and then some C written here. A lot of games actually do that where they have like Lua kind of on the side. And how you interact between the two is if you have just a general C library without any Lua interaction, you can just run whatever function is in that C library. So if you have a .lib or a .a, then any of the defined functions you can run with Lua. That's kind of one way to embed it. The other way to embed it is to intentionally embed Lua if you're using it. So this is the packaging for Lua 5.4 in Ubuntu. You don't need to know anything about Debian packaging or anything. But one of the things I did when I included 5.4 in Ubuntu was add some tests for it. So one of my tests was to basically run the Lua library within C and determine if Lua was working properly just to make sure Lua runs. So yeah, okay, so this is just a bash file. It's something I wrote 14 months ago, apparently. But the important part is I'm creating a file called libluatest.c, and you can include the Lua C library here and the Lua library here. And here's how you create a Lua state. So Lua L new state, that's basically a user data item, and it creates a Lua stack within your C library or your C program or whatever. And that Lua stack is what you can directly interact with on both the Lua and the C side. And that means I can load a Lua file called test scripts. Here's test script. It just basically prints some dots. And by loading that file, I can run it with the Lua pcall command, and then it'll print out those dots. And I can close the file, that sort of thing. So there's basically a Lua library in C that you can run Lua from C, but you can also run C from Lua by creating a user data object in Lua. Yeah. And here's me running it. So you just have to include the Lua 5.4 library in GCC.
Cool.
Have you tried creating like the same project in Lua and in another language or engine and do a comparison of like what the experience was like?
I guess I haven't done that personally before. It would definitely vary a lot. I mean, it also varies on what project you're doing. Like if you want to do something very intensive, like, I don't know, some fancy game with like a lot of particles and they're running around and like assets and stuff, then it'll probably be easier to use like Unity or Unreal. But if you want a nice like 2D platformer or like a sort of retro-y game, like say you want to recreate asteroids or something, this is a perfect engine for that. Just because it's nice and easy, it's quick, rapid development, and it gets you just a 2D screen as quickly as possible.
Do you use any entity systems, or like trying to think about ways that people tend to manage complexity? And like to your question, I think about Godot. Godot has a whole like scene graph
Yeah.
of node hierarchies and stuff, which reminds me of entity systems. I don't know if it's a fair comparison, but are there tools like that you reach for, or can you comment on like how you have structured games in the past? I'm trying to figure out like if I was to write a game, what would I be loading versus like where to put what is sort of the questions in my head.
That makes sense. Yeah. It's hard to do like a scene graphic per se because you don't have that physical interface of your application that shows off like a little screen graph. But you can kind of do that because you can have like your physics world or whatever and graph out from that, because a world contains a certain set of bodies or whatever, and those bodies can be attached or connect to other bodies, but there's not so much a graph of scenes. The best way to do a scene graph is to have a new file that you load in whenever it's that file's turn, and you can basically, because since a function is a variable in Lua, you can have a function that calls like draw this scene or whatever. So it's this scene.draw, and it can be any of those this scene.draws, and you can just set your function call in your love.draw to whatever that scene is. And that's usually the best way to go around it, is making it dynamic with like the same sort of set of functions in each scene. At least that's how I've done it. But I mean, you're free to do anything because it's just a programming language.
Are there ways to incrementally load? Like, so you have the went over the love.load hook at the beginning, which is where I would think about loading in image files and that sort of stuff. But that could be a lot of image files that maybe you don't necessarily need right away. So, are there techniques that you've seen to kind of delay some of that evaluation to when they're needed?
Yeah, I think the general technique there is like if you're using one file per scene or something, then declaring your image variables and all of those locally to the file, because you can do that. So if you just say local whale equals whale image at the very top of your file, it's local to that file. So it'll load in once you load that file. But that depends on when you're loading the file. So like you'd basically want to run a custom load function in whatever scene you're using, and then that can contain all of that, and you would load that in maybe after some sort of
animation.
Yeah.
People are used to those. Okay. All right. Cool.
So aside from an program for sending innocent whales to space, what have you actually built with Lua?
Well, when I was younger, I built like a few platformy sort of things. I've never released a full game or whatever. Love. Game development's not my job, actually, but yeah, I've written a few platformers. I wrote one with like a little hacker guy that you could type in a command line or whatever, and you could hack little things. That was fun at the time. I don't know where that is. It's probably somewhere in my archive, not on this computer, unfortunately, because it's my secondary. I've written like an asteroids clone before. That was pretty fun. And yeah, that's about it for Love. I've done a lot more with Lua specifically, because I work a lot with like Wireshark, and that has Lua scripting in it. And on Minecraft with the ComputerCraft mod, that has a full Lua interpreter in it, so you can run Lua there too.
Cool. Doesn't Roblox also use Lua?
Yes. Yeah, it does.
Other questions?
Does the language have a try catch, or is it like Go where you return an error?
Yeah, it doesn't have a try catch sort of system. You only have your if statement. So like, I guess at the
They've got pcall, which is
it does have pcall, but yeah, it's hard to do a try catch in Lua.
So you would do it like people do in Go, where you return an error as like your second argument to a function, and they do if error is nil or not nil.
Yeah, you could do it that way. And it's very dynamic, like what you return and what you send. Like you can do any number of values. So you can do like return your return value, comma, your error, send that out, and you can set those equal. Yeah.
Well, cool. Thank you very much. Appreciate it.
Yeah.